Okay, in this episode, we're going to go ahead and take a look at all the fun stuff we can do with functions, considering you can't spell function without fun. Haha. Anyhow. So let's go ahead and take a look at the things that are considered these fun stuffs to do with functions. So we are going to go ahead and be able to answer the following questions. How do I perform arithmetic combinations of functions, and how are they represented graphically? How do I build composite functions and determine their domain? How do I build an inverse function algebraically from an original function? What are the characteristics of an inverse function? And what is a one-to-one function? And so what we're going to be doing, and we got some vocabulary word, and we may have seen this in the past, hopefully, and we're just taking a look at our functions when we're adding them. We're going to use this notation: subtracting, multiplication, division, and then plugging a function in a function. Okay, an inverse function is going to be something that we're going to be looking at in depth later on. But the bottom line is, for right now, is that if we have an f of x and g of x is going to be an inverse, which we're going to discover later on, we're going to call the g of x the inverse of f of x. And the inverse has this notation right here. It does not mean this, okay? Even though it looks like it should, it doesn't, trust me. And so we're going to be building our own inverse functions and whatnot, and unpacking that a little bit later. Just need to stay tuned. And we also are going to be finding out what a one-to-one function is, and taking a look at when an inverse of a function is a function also. So all that good stuff that we're going to be rolling into, and yeah, let's go ahead and start our adventure. All right. One skill that we're going to go ahead and have is to be able to do some fancy algebra when we are building inverses. And so one of the things that, and I just need to change this to y real quick in order for this example to make sense, is that we're going to go ahead and we're going to take this equation right here, and what we're going to do is that we're going to get it such that x equals, and on this side, we're going to have the things in terms of y. So it's going to be x, the value of x in terms of y. So we're going to have to do some fancy algebra to switch things around to get the x all by itself, if you will. And so first thing I'm going to do is rewrite this. Okay. And so here we go. We're trying to get x all by itself, and this is might seem a little bit tricky at first, but after a few times over it, you'll be able to go ahead and do it out no problem. So the first thing I want to do is that I want to multiply each side by this guy right here. Okay, and so that's going to wipe out this, and we're going to get this y times 5x plus 1 equals 2x minus 4. So what I want to do is I'm going to rewrite the step, clean it up a little bit. Okay, and what we're going to do is seem like we're going to make a little bit of a mess here, but it should make sense when we see the entire thing done out. So I'm going to distribute the y in, and I'm going to get 5xy plus y equals 2x minus 4. And so since I want to get x all by itself, what I'm going to do is that I'm going to move the 2x on over to the left-hand side and cancel those out, and I'm going to get 5xy minus 2x plus y equals a negative 4. And then I'm going to go ahead and I'm going to throw the, let's see, I'm going to go ahead and move everything that does not contain an x on over to the right-hand side. And so I'm going to put this y over here. And that is going to go ahead and cancel out. and we get 5xy minus 2x equals a negative, well, let's put the y in front, negative y minus 4. Okay, so just to recap, we're trying to get x all by itself. And it looks like we're stuck because you notice with these two terms right here, these are unlike terms, and we can't group them up to get it down to 1x. But what we can do is that we can factor out an x like this, okay? And we can put that on the outside. So let's go x, factoring it out of the first term. That leaves us with 5y minus 2 equals negative y minus 4. And then finally, if I want to get x all by itself, I can divide each side by the 5y minus 2 and 5y minus 2. Those cancel out, and I get x equals negative y minus 4 all over 5y minus 2. So you may have to do some pretty uncomfortable algebra in this section when we are basically solving for a variable like this x, if you will, that's buried in a few different places in an algebraic equation. And so this is just kind of a preview of what you might be up against, just like this next example. All right, so the first one that we tackled was a rational, that guy right there. And this guy right here is a cubic function. I just want to go ahead and see some algebra with this, okay? And so basically we're going to do the exact same thing. We want to get this in terms of y, so that means is that we got to get x all by itself. And so here we go. I'm going to rewrite it. And so let's start building this thing. Okay, is that I want to get x all by itself, so my first move is that I'm going to subtract 10 from each side. And that's going to give me y equals, I'm sorry, not y equals, y minus 10 equals a negative x minus 3 to the third, all divided by 2. Okay, and so what we want to do next is that I'm going to try and move the negative and the 2 to the left-hand side with one step here. So I'm going to multiply each side by a negative 2. And I got a negative 2 right here. And so negative times a negative, that's going to cancel those out. And then the 2 divided by 2, that's going to cancel those guys out. And so I'm going to get negative 2 times y minus 10 equals x minus 3 raised to the third. And then I'm just going to distribute in. So I'm going to get negative 2y and then plus 20 equals x minus 3 to the third. Now, what I'm going to do here is a trick that we learned in our math 2 and 3 days, is that to undo this guy, I'm going to raise each side to the 1/3 power, like this. And the reason being is that when we raise a power to a power, we multiply these together, so 3 times 1/3 is going to give me 3 over 3, which is this 1. So it kind of cancels that way out. And so we're going to get negative 2y plus 20 raised to the 1/3 power equals x minus 3. And then the only thing that we got to finish up is to add 3 to each side. And I'm going to go ahead and put this out of the way. And that is going to give us then, I'm going to write x first. So x equals negative 2y plus 20 raised to the 1/3 power plus 3. And now we have this x in terms of y. So again, that's going to be something that we are going to be using quite a bit in the upcoming parts of building inverses algebraically. But this gets us, again, kind of primer in the algebra that's needed and what lies in wait for us. So that's how you do that, and on to the next part. All right, so here we go with understanding the function notation. And basically, we're just going to go through some examples of function notation and how it's going to relate to these arbitrary functions that I made up for the sake of the lesson. So this first guy is saying f of 3 minus g of a negative 2. So basically, we want to find out what f of 3 is and g of a negative 2 and subtract those. So let's do that. So we got f of 3. And that is going to equal 2 times 3 minus 1 equals 5, last time that I checked. And then we got our g of a negative 2, so I'm going to be plugging it into the g of x. And by the way, I am referring these two guys right here, if you haven't caught on so far. And we get 6, and then I got a negative 2 squared plus negative 2 minus 2. And so, looking at this, we get 2 times 2, which is 4, 24, right? Okay. And times 6, and we get 24. And then we got minus 4 right there. And then we got this business of 20. Okay. So now I know what f of x is equal to, and I know what g of x is equal to. And so now I can just say, all right, let's take a look. F of 3 is going to give me 5 minus g of a negative 2, which is 20. And so this is going to give me negative 15. Okay, in this next example, it looks like we're dividing this time g of x and f of x, and this time we're not plugging in actual numbers, getting values, and then doing what we need to do. In that last case, we were subtracting. This one, we are saying that g of x, which is 6x squared plus x minus 2, all over 2x minus 1. And so what we're going to go ahead and do is that we're going to, well, first of all, understand that we got that set up. That's what our division is going to look like. So we're building a rational from it. And we also might have to go ahead and check to see if we could reduce this thing any further, okay? Because sometimes the top part can go ahead and factor into two things being multiplied by one another and then cancel out with the bottom part. So let's go ahead and factor the top. And I'm going to do it off to the side here. So 6x squared plus x minus 2. I'm going to multiply that and get x squared plus x minus 12. Negative 12, 1, and we got a 4. Look at there. And so, looks like we're going to be on our way to being able to factor this guy out. And we are going to divide by 6, reduce. Okay, that reduces down to minus 1 over 2. And now we can put those numbers back in front, and we end up with 3x plus 2 multiplied by 2x minus 1. And so I'm going to use this right here to rewrite the numerator and see if something is going to cancel out. Okay, so there is the numerator rewritten, okay? And it looks like now we could cancel out these guys because they are in common. And so therefore, we would have 3x plus 2 as our final part that we're going to go ahead and this will be the final simplification, okay? So, to put in a nutshell, we went ahead and we built the function, okay? Put g on top of f, and then we had to factor g down below, and then we returned it on over to the numerator where cancel those guys out, and we were left at this as the final build, 3x plus 2. All right, in this next example over here that we have this business of h of x, and it looks like in h we are plugging in 16x to the fourth into this guy right here, okay? And it looks like we're also multiplying that by 3. So let's pick that apart. So we start off with h of x, and h of x is just going to be the square root of x, right? As it's defined right here. The 3 on the outside says that we're going to multiply that by 3, okay? On the outside of the function. And on the inside, this right here, we're going to change this x into the 16x to the fourth. So we would rewrite as, we would have the 3, the square root, and we're going to take this 16x to the fourth, and we're going to put it under here, okay? And so, that said, is that we probably have some simplifying to do, and we're going to take a look at real quick just if we have two things that are being multiplied, being multiplied by one another under a radical sign. You could take the square root of each one of those separately, and that will work, okay? So what we're going to do is that we have 3, and I'm going to take the square root of 16 and the square root of x to the fourth, and just kind of break them down, right? Is that this is going to be 4 times 4, so I know that the square root of 16 is going to be 4. And I got this guy that breaks down to x squared times x squared, so I know that the square root of x to the fourth is going to give me x squared. So I would have 3 times 4 times, and these guys, x to the second, and then clean it up, I would have 12x to the second, okay? And so, when we're in this section, okay, is that we're going to have a bunch of different ways to manipulate functions using this function notation, and we're just trying to get as many looks as possible, seeing what could happen and how to simplify up. So that would be the final answer for that guy right there. So let's take a look at the next one. Okay, so this is what is called a composite function. And what this basically means is that we're going to be taking f of x and plugging it into g of x. So you always plug this function into that one. So that means is that I'm going to take the g of x right here, and every x in that g of x is going to turn into f of x, which is this guy right here. So I write from g of x 6. Now this is usually it would be x squared over here, but instead I'm going to write 2x minus 1 and then square it up. Plus, typically it would be x, but instead I'm going to write 2x minus 1 and then finish it up with the part that doesn't change, the minus 2. So from here, I have to go ahead and FOIL this guy out and start to go ahead and gather up some like terms. So 6, and I'm going to FOIL this out. So it would be 4x squared minus 4x plus 1. And then I can start to get these guys, because all done up, drop the parentheses. Okay, so it looks like outside I'm going to gather that up and get a negative 3 a little bit later, but let me finish this first. And then I'm going to distribute the 6, which is going to be 24x to the second minus 24x plus 6 plus 2x, and gather these guys up, minus 3. And now to end things up, we end up with 24x squared minus 22x, and then gathering this up, plus 3. So that's how you would do the composite function when you're plugging a function into another to go ahead and create another function. Okay, so it is just like very similar to the difference quotient that we did in regards to plugging functions into one another. So if you think about it like that, because remember we were plugging, oops, that was strange, x plus h into functions for the difference quotient. So if you think of it not too differently from that, then it might help you visualize how to go ahead and do these out algebraically. So let's take a look at this last one. All right, and this last example that we're going to go ahead and tackle, it looks like we have g of x once more up, and it looks like we are plugging in, so let me clear out all that stuff around g of x so we can read it. And it looks like we're plugging t squared minus 1 on into g of x and then multiplying the whole thing by 2. So let's go ahead and set that up. So I know I'm going to multiply g of x by 2, all right, the whole thing. And so I'm going to then start loading in the t squared minus 1 for x squared. So I get 6 times t squared minus 1 and then squared plus t squared minus 1 and then minus 2. All right, so what we can do is start cleaning things up, and I'm going to go after this first, okay? And so when I FOIL that out, which is going to be like this right here, okay? So when I FOIL that out, that's going to give me t to the 4th minus 2t squared plus 1, and I just said 2d. Haha. And when I put t to the 4th there, that is an awfully big 4, so let me go ahead and fix that. All right, and so starting to open this back up then, I have 2 times 6 times t to the 4th minus 2t squared plus 1 plus t squared minus 1 minus 2. So I can drop the parentheses on this guy right here. And then I want to just go ahead and let's do the distributive property right here. So I'm going to distribute that 2 in, and I'm going to isolate out that part. So I go 2, and I'm going to have 6t to the 4th minus 12t to the 2nd plus 6 plus t to the 2nd minus, and then I'm just going to combine those guys up, 3. Okay, so combining things up inside there, because I'm going to leave that 2 outside until I'm done with all the brackets there. So I'm going to bring that down, and I'm going to have 6t to the 4th, and then I have, it looks like, a negative 11t squared, and then this part right here, that's going to give me a plus 3. Oops. And then finally, I can go ahead and just double all the coefficients there, and should be done. And so that is going to give me 12t to the 4th minus 22t to the 2nd plus 6, and that is going to go ahead and take care of that entire expansion there. So that's a good idea of what our function notation we're going to need to have down, so we can proceed with the lesson there. So we're going to go on to the next part, and I'll see you there.